Hi, I'm Matt, and welcome to Learning JavaScript Promises, Practical Applications in ES6 and AngularJS by Pact Publishing. I've been working with lots of JavaScript, mostly Angular and Node, for about 3 years, which is also around the time I discovered how great but sometimes troublesome asynchronous programming can be. When I found out that promises were going to be part of ES6, I got really excited because on a daily basis, promises help me solve issues such as race conditions, callback creep, missed events, and more. In this course, we will cover many features of promises, from the most basic to some pretty complex asynchronous flows. And the examples we will use to illustrate those will be both practical and fun. We'll start off with introducing promises and how to use and create them in Angular. We will then see what we can do with promises and what kinds of problems they help solve. And this time we will do that using the ES6 implementation, so you'll get a wide coverage of both Angular and ES6 promises. We'll continue with planning and executing asynchronous flows, including handling both successes and failures. And all the while we will be using real-life examples, showing how each of the tools will actually help you develop your own applications. In the same vein, we will then learn to combine promises into easily understandable and clearly coded processes. By the time we reach the last section, you will be perfectly comfortable with promises and what they can do, and so we will learn more advanced tips and tricks that I've discovered through my experience with promises. Throughout the course, we'll be building cool widgets, each using a particular feature of promises, and you'll discover new browser capabilities. We'll have the browser speak, read and display the current battery status of your device, a weather forecast, and even a small car racing game. All those widgets are actually demoed at this URL, and all the code for them, each of the steps, will be available on a Git repo, which you can also use to get in touch with me if you have any inquiries about the course. Now that you know how the course is going to progress, let's dive into the first section of our video course, Introducing Promises. A lot of processes and actions in JavaScript are asynchronous, meaning that they are handled independently of the main program flow and processed in the background. Whether we are looking at browser-side or server-side, this is one of the attractive features of JavaScript. But asynchronous coding can be slightly confusing. Async functions return immediately, and the main process or thread continues with other things, while those functions complete their task in an unknown amount of time. So the flow of actions need to be planned properly, and the code needs to be structured well and clearly to avoid running into problems. Promises are basically a pattern that provide a solution to that effect. So in this section, we will introduce deferred objects, which represent an asynchronous action, and more importantly, the promise objects, which represent the result or outcome of these actions. We will see how they are used by built-in Angular services, as well as how you can create your own promises to handle an asynchronous flow. We will quickly set up Smashboard, a widget dashboard page, which will be our supporting example throughout the course. In this first video, we will use Angular's built-in services to show a simple use case of promises, and you'll notice that you have probably been using promises before, without necessarily knowing it. To be more specific, we are going to make an AJAX call and thus use the promise returned by Angular's $HTTP service. We will apply that to create our first widget, one that grabs data from a RESTful API and displays the result on screen. Let's dive into our Smashboard application. As you can see from the code bundle provided, we have set up a very simple Angular page with one HTML file, index.html, and one app.js file, which will contain the JavaScript code and Angular application. The index imports external JavaScript libraries such as Angular, Lodash, and Moment.js for date manipulation. It also contains Bootstrap CSS, so we can prettify the application a little. Here we've simply created a generic Angular app and assigned it to the entire body using the ng-app directive. We've also assigned a TV controller to this div element here, which will contain our first widget, a very simple TV guide which loads data via AJAX. You may use any form of web server to serve this file. I personally use Python's simple HTTP server. But make sure that you are serving that file though. Do not simply open it directly in Chrome, or you will face some security restrictions on AJAX calls, etc. And here's what our application currently looks like. Let's open our template, index.html, and look at the markup for the TV guide widget. As you can see, we are expecting the scope to have a channels array so we can repeat over it. And each item of that list will have a name and a service ID, which is the channel number. If that array of channel is empty, we will show a message saying we're not sure what is playing. That's the role of the two ngIfs here. Let's switch to the JavaScript side, app.js, and start coding the loading of data. We will be using an API, and here's the URL. You can open that URL in a browser to see the response we are expecting. And since we are going to make an AJAX call, let's request the $HTTP service into the controller by simply typing $HTTP as one of the parameters. Now, AJAX calls are asynchronous, as the name implies, and you need to remember that in async programming, calls return immediately, and that your original process will be informed that the action has completed after an unknown amount of time. That's different from synchronous programming, where your main process waits, and the return value of the function is your outcome directly. So when calling $HTTP.get with the URL as the first parameter, we cannot simply set $scope.channels to be equal to $HTTP.get, because that AJAX call does not return the response from the API. Instead, $HTTP.get returns a promise object. So we will write var AJAX promise is equal to $HTTP.get, brackets, and the URL. Now this promise object has, amongst others, a .then property, which is a function. And that function takes a callback as an argument to tell it what to do once the AJAX call has completed. So let's type .then brackets and a function, which I will name WeGotData. Just a word on callbacks. A callback is just a function. It can be an anonymous function, a named function, or the method of an object. We name them callbacks because they are called only when a certain process is completed. Think of callbacks as a closed letter containing instructions that you pass to someone for them to open only once a first action is completed. For example, I can ask John here to go to the shop, and once he's there, open these instructions I'm giving him. When John reaches the shop, he opens the letter, and there's me asking him to buy ice cream and then come home. So that set of instruction, that letter, is a callback. Notice that we should not call or execute the callback method. That's the equivalent of opening the letter. Instead, we should allow John to do that when he's ready at the shop. Programming-wise, it means that callbacks, though declared by us, will be executed by the asynchronous process instead. So back to our callback, which will execute once the API call has completed. $HTTP.get will pass a certain argument to that callback. And that argument is actually the HTTP response object. And so what do we want to do with the response once we have it? Well, we want to set the channels on the scope to be equal to the data received in the response. So $scope.channels equals response.data.events. That last bit depends on your API, of course. Let's have a look at the result in the browser. Depending on your internet connection, you will see the "I'm not sure boss" message for a short while, and then the data will have been set to the channels array, and our widget then displays what is currently showing on TV. If you open the developer tools, you will see the AJAX call, as well as the time it took to complete it, which can be quite random, as you can see by reloading the page several times. Congratulations, you have built your first widget using promises. Feel free to play around with the response to the AJAX call and to personalize the widget. So in this video, we met with our first use case of promises, one that you might actually have encountered before, namely AJAX calls. We also set up our dashboard page and talked about callbacks as being simple functions containing instructions for what to do next. Of course, this was possible because $HTTP returns promises, but there will be many cases where the actions you want to execute do not use promises. So in the next video, we will learn to create our own promises and use them to handle an asynchronous flow. In the previous video, we used the $HTTP service to complete an asynchronous API call, and that service returned a promise directly. There are still many processes, though, that have not yet adapted to promises, and so in this video, we will learn how you can create your own promise objects to handle an asynchronous flow. This will mean creating a deferred object, which represents an asynchronous action, then starting the process, and finally handling the outcome using the promise object. For this, we will create a second widget which will display your current latitude and longitude as given by the navigator's geolocation. Let's have a quick look at index.html, and you can see that we have set up the second widget with its own controller, location controller. The two ngbind directives here show that it is expecting that we will define a coordinates object onto the scope, which has latitude and longitude properties. Let's now open app.js and take care of the actual logic. We've already set up the controller, and what we're going to use is the navigator.geolocation functionality. And if you're not too familiar with that API, I suggest you read up a little on mozilladevelopers.org at this link. We will use the getCurrentPosition function, so window.navigator.geolocation.getCurrentPosition, and that function takes a callback as parameter, which itself receives a geoposition object. Now that API is clearly asynchronous, but it does not use promises and actually is not even part of Angular. So for us to be able to use promises, we have to create our own. This is done by using a service in Angular called $Q. So let's request that service in our controller here by simply adding $Q to the parameters. And we are going to create an object, let's call it var getGeo, equals $Q.defer, and in brackets. And now getGeo is a deferred object that will represent the asynchronous process of getting the current location. Now inside the callback of getCurrentPosition, we know that the action is complete. So we're going to write getGeo.resolve, which signals that the action is done, and pass the geolocation object along to declare that this is the outcome of the process. We will dive deeper into resolve and the outcome value in section 2, but for now, let's focus on the fact that we have created an object that represents an asynchronous action, and told that object that the action is complete once we receive the location from the browser. Time to handle the result of the action. Every deferred object, such as our getGeo variable, has a property which represents the outcome of the action. It is called .promise, and as you would expect, it is a promise object. This promise object works exactly the same as what we got from $http.get in a previous video, meaning it has a .then method, which takes a callback, a set of instructions basically, to decide what to do next. That callback will receive the geoposition object as a parameter because that is what we passed into the resolve function here. For your information, here in the corner, I'm showing what a geolocation object looks like. You can see it has a coords property, which looks exactly like what we need for our scope's coordinates. So what do we want to do next? We want to set the coords property onto the scope, so $scope.coordinates equals geoposition.coords. Remember that in the template, the scope variable expected is called coordinates. Let's have a look at the outcome in the browser. Make sure to agree to provide your location when the browser prompts for it, and after a couple of seconds, you can see your current location displayed in the widget. So back to app.js, and if you are wondering what is the advantage of forcing a promise instead of just using a callback for the getCurrentPosition function, you will discover during this course that promises are really great when working in more complex flows, where you need to change behaviors, have several processes in parallel or one after the other, etc. But even at this stage, if you have any experience in Angular, you know that this process here would need to be extracted out from the controller and into a service, as I am doing now. We create a location service factory and use that instead of $Q in the controller. That service returns the promise object of our getGeolocation flow. So the controller is now lighter, as it should be, and receives a promise from getGeolocation, which makes it extremely easy to handle on the controller side. It also makes the process reusable in another controller if needed. So to summarize, although in this example it might not look like a great improvement, promises will definitely allow for cleaner and more reusable code. So in this section, we have dealt with two types of objects: deferred objects that represent an action, and promise objects that represent the outcome of the action. We have seen how $HTTP returns promises, and actually most Angular services will return promises when dealing with asynchronous flows. And for the cases where promises are not implemented in the API, we have learned how to create our own deferred and promise objects. Now in this section, we used .resolve on deferred objects to signal the end of a process. Actually, there are always two possible outcomes for an asynchronous process, success or failure. We will cover that in the next section. Also, in that section, we will be using ES6 promises instead of Angular promises and highlight the similarities and the few differences. Welcome to this second section of the course, Resolving and Rejecting ES6 Promises. In the first section, we spoke about Angular promises. But promises have become such a popular feature that the new iteration of JavaScript, ES6, implements the Promise API. Of course, since ES6 is not completely rolled out yet, not all browsers support this API, so please make sure to use Google Chrome during this section. So in this section, we will first look at how to create ES6 promises, which is very similar to the Angular way. We will talk about the two possible outcomes of a promise, which are either success, which we call resolve, or failure, which we call reject. This will lead to deciding what to do once the promise is settled by adding callbacks to the promise. And we will see the characteristics of the resolution of a promise, namely that it is a single chance and single value process. We will talk more about the execution of callbacks added for success and failure. And finally, we will have a very brief look into the proposed Angular 2 Promise API. The first video is creating ES6 promises. In this video, we will first take a look at ES6 promises, whereas so far we had used Angular promises. But you will see that they are very similar. We'll use the so-called executor function to build our own promise and learn how to complete the promise with either the success or failure function. As an example, we will make the browser talk and display a message when the speech is over. Let's open our index.html file and refer to the div I'm highlighting. You can see that we created a box for the widget and an input where you will be able to type the text you want spoken out. There's also a span element here which will show a status. To avoid having an extra button, we will just listen to the blur event on the input. For convenience purposes, we gave each of those elements an ID, so we can select them easily later. Note that this time we did not define an Angular controller because we are going to code this in plain JavaScript without using Angular. For this example, we are going to use the speech synthesis API, so once again, please use Google Chrome. For those who do not wish to use Chrome, I will type an alternative example where we simply wait for a random amount of time. Now let's move to the JavaScript side, app.js. The first thing we need to do is to set the listener on the input. That needs to be wrapped in a DOM content loaded event, just as you would usually do a $document.ready in jQuery. So document.addEventListener, DOM content loaded, and we're going to first assign the two DOM elements we care about to a variable. Conveniently, they each have an ID, so var input equals document.getElementById, say what, and then the same for the output span element. On the input, we are going to add an event listener for blur, and that will trigger this here callback. Let's add a console.debug inside that callback, just so that we can see the flow of things later on. Now comes the part where we are going to use promises. So let's create our ES6 promise by typing var speaking is equal to new promise. And as an argument, that constructor takes a function which we call an executor. That function itself receives two arguments, which for now I will call success and failure. Those arguments themselves are functions which we can execute to signal the end of the process. The executor function does not need to be named executor. Any name or even an anonymous function would be fine. The executor function is roughly the equivalent of Angular's deferred object, which, as you remember, represents the action itself. So we will be running the actual process from within that executor function. In our widget, it means first creating a speech synthesis utterance object, which is basically a message with the value of our current input as the actual text to be spoken. And next we will add the speech synthesis API to speak the message out. At this stage, we have not yet told the promise when it is settled or done. We saw in the first section how to transform the geolocation service to use promises. Geolocation was originally callback based. Remember that getCurrentPosition took a callback. Now the speech synthesis API is not callback based, it is event based. And by the way, there you have the three common ways of handling asynchronous processes: events, callbacks, and promises. We will look at advantages of each one in section 5. But back to the speech widget. We need to listen to the end event of the message object. So message.onEnd equals to a function, and in that function we will acknowledge that our speaking process is complete by executing the success function that we received in the executor. The onEnd function receives an event as parameter, so let's pass that along as well to represent the result of the process. If you decided not to use Chrome and the speech synthesis API is unavailable, you can replace the actions in the executor function by waiting a random amount of time. Let's create a random amount of time between 0 and 2 seconds, so math.random times 10,000, since JavaScript timeouts take milliseconds. Then set timeout function, and we trigger the success function. And in order to match the event we get from the speech synthesis, I'll just give an object with elapsed time, colon, and then the duration. We trigger that function after the random amount of time, duration. Alright, so even if you don't have the speech synthesis API, you'll be able to see this example work. Let me revert to the speech code. So now we have a promise object which will be created by the executor function, and after a certain amount of time, the executor will acknowledge that the promise is complete or settled. So now we need to handle that outcome. In the same way as Angular promises do, the ES6 promise has a .then method, which takes a callback, and that callback will receive one argument, the one that we passed to the success here. So what do we do with that? Well, in the output span element, we're simply going to display a message, speech completed in, and we'll use the event's elapsed time value to complete the message. Let's also add a console debug of the event object so we can see things happening clearly. And a final touch, outside of the executor, we'll write speaking in the output span so that while the process is going on, it will display that on screen. Alright, let's now have a look at our widget in the browser. Open the developer console so you can see those debugging logs. Type something nice into the box here and you will hear it spoken out as soon as you exit the input box. The status text changes to speaking, and when done, it changes to the message we had created. Note that the number of seconds is a bit messed up here because this API is still very much in the development phase. Now before we complete this video, allow me to just discuss a coding style thing here. If you go back to app.js and look at the onEnd part, we are creating an anonymous function which receives an event, and then we are simply calling the success function with the exact same argument. Now in JavaScript, functions are first-class objects, so they are exactly like other variables. And we can do without the anonymous function and simply write message.onEnd equals success. There's no need for brackets, as the success callback will be called only when the speech ends. This is considered cleaner and works to the same effect. It is okay, however, if you are more comfortable with creating the anonymous function. So in this video, we learned about ES6 promises, and we created one such promise to handle an asynchronous process. In the executor function, there were two functions, success and failure, but we only used one. So in the next video, we will learn how to use the second one, and we will discuss the only two outcomes that any promise can have, resolved or rejected, and how this affects coding with promises. Welcome to video 2.2. As the title states, promises only allow for two outcomes, success or failure. In the previous video, we created a promise object and made it complete by calling a success callback. So far though, we have been resolving all our promises, meaning we have assumed they are all successful. But in every process, there's a potential for things going wrong. In this video, we will go through signaling success using resolve and signaling failure using reject, as well as how to handle the outcome of both cases. We will also briefly have a look at the ES6 promise object itself and at its status internal slot. To illustrate the concept of resolving and rejecting as the only two possible outcomes of a promise object, we are going to create a simple game widget, the 5 seconds challenge, where your task is to click on a button and try to hold it down for as close to 5 seconds as possible. Let's open the index.html file and see that we have prepared the markup for the 5 seconds game. It consists of a button, to which we assigned an ID for convenient referencing, and a span element with an ID of last, in which we will output the time the player held the button down. The rules of the game are simple. The player clicks on the button, we start a timer, and when the player releases, we give the elapsed time. However, if the player moves the mouse out of the button area before having released, we will consider that they have given up and we will alert a message. When working with promises, it's always a good idea to write down the process flow, and as things get more complex, to even write a table showing all the various paths. Let's do this for our game. We'll represent the entire game process with one box, and it has two outcomes, success being the player finishing the game, and failure being the player giving up. Now within that process, we only have one asynchronous action. The mouse is pressed down on the button. And that can only have two outcomes. Either the player releases the button, and we will consider that a success, or they move the mouse out, and that will be a failure. Now because this is a very simple example, success on the mouse action means success on the game process, and failure on the mouse click means failure for the game. Let's translate this into code. Open app.js, and within a DOM content loaded, we will first keep the two important elements in variables. So var click equals document.getElementById clickMe, and the same for the span with the ID last. And we need to listen to the mouse down event on the button. So click.addEventListener mouse down. And within that mouse down event, we will create a new promise with an executor function. Var clicking equals new promise. Remember that the executor receives two parameters, which previously I named success and failure. But let's get used to the correct conventions and call them resolve and reject. Within the executor, first we will start our timer simply by keeping a start variable, which is a new date object. We want to add two event listeners at this stage, one on mouse out and one on mouse up. Now in this very specific case, we actually want to make sure there is only one event listener for each mouse out and mouse up. So we will not use addEventListener, but rather directly set click.onMouseUp equals to a function. And this represents success, so we will use the resolve function. Let's quickly add a console debug here for later. Now mouse up represents a success. But that is not enough information. We also want to tell the promise that it succeeded with a certain value, which here would be the elapsed duration. We can get that from a new date minus the start date. That will give us the number of milliseconds since the start of the click. Now the mouse out event will also be a function, and we will reject this time because mouse out represents failure. We can reject with a value or not, and in this particular case, let's reject with a message saying you left the button. So the executor part is now complete. We have handled the various paths that lead to failure and success. It is time to handle the outcome of our process. As always, the promise object, clicking, has a .then method to which we can pass a callback to handle the resolve case. So clicking.then function And that function receives the argument that we passed in resolve, which is the duration of the click in milliseconds. But .then can also take a second function, which represents what to do in a case of failure. So comma function with a message parameter if we want it. Alright, and what do we do in each case? When resolved, we want to display the number of seconds, so duration over 1000, as the text of the span element. And in case of reject, let's simply alert a message saying challenge is incomplete. And there we have completed a promise with its two possible outcomes, resolve and reject, and handled what to do for each of those cases. Note that since we do not care about the reason for rejection here, and if we are okay to do without the console debug, we could more elegantly write click.onMouseOut equals reject without brackets, meaning when the mouse goes out of the button area, I want you to call the function reject. Let's have a look at the result, and you can see that the game behaves as expected, with an alert if we exit without releasing, and a score displayed here otherwise. Let's now open the browser's developer's console, and you can see the debug logs being displayed in here. But let's use that developer console a bit more, and in the sources tab here under localhost, you will find the app.js file. Let's add a breakpoint by clicking on the line number here where we have clicking.then. There's no need to reload the page, simply click on the game button as before, and you will see the execution pausing at that line. When that happens, let's create a variable in the console that refers to our promise object. Simply type p equals clicking. Immediately you see the output stating that p is a promise object, and you can actually even see the property, or to be correct, the internal slot, for the promise status, which right now is pending. You can recognize that it is an internal slot because of its double square brackets in the representation here. If you try to type p dot and let Chrome autocomplete with the methods and properties, you'll notice that the status doesn't show, and that is by design because internal slots hold information that you're not supposed to access. If you ever need to read a promise's status, then you probably need to rethink your code. Now let the execution continue by pressing F8 or clicking on the play pause button here, and finish your round of the game. In the console, you should still be able to access the p variable, so just type p enter to display it. And you can see that the status has changed to either rejected or fulfilled. The promise value here, which is also an internal slot, should contain the outcome value. And that gives you a little peek into the internals of promise objects. And in this video, we created a full, although simple, asynchronous flow with two possible outcomes, a success and a failure. From now on, we will always refer to those as resolve and reject. We did handle the outcome of both cases, but in the next video, we will look into alternative ways of coding what needs to be done next, and we'll discuss why people refer to promises as the asynchronous try-catch. In the previous video, we focused mostly on the asynchronous action itself, though we also handled the resolve and reject outcomes. In this video, we will review how to write handlers for process flows where we need to handle resolve only, both resolve and reject only. We will also highlight how promises flow behave very similar to a synchronous try-catch, and that will lead us to introduce an Angular-specific feature, the .finally callback. This time, we are going to create a widget to display the current battery status. Once again, please use Chrome to ensure that you have this API available. We will display the battery level and whether your device is currently charging or not. This will also work on desktop computers, by the way. It will just always show charging and 100%. Let's open the index.html file and see that we have prepared the markup for the battery status widget. We simply have a charging status element with an ID and a level element with an ID as well. And the reason why I'm using an I element here is because we will use Font Awesome to show a little battery icon with different levels. You can see that Font Awesome is loaded via a CDN link at the top of the HTML file, and here's a link to the Font Awesome site for your reference. Let's now switch to app.js, and once again, let's wrap our calls into a DOM content loaded event to ensure that the DOM elements are present. We will keep a reference to our two DOM elements, var charging equals document.getElement by ID charging, and the same for the level, which has the ID battery level. Now to the battery API itself, it is called navigator.getBattery, and that API is one of the first features in a browser to actually directly return a promise object. Many APIs return promises in frameworks such as Angular, but this one is browser native. Expect more and more APIs to behave like that in the future. Now that means that we can write var battery promise equals navigator.getBattery, and battery promise will then be a promise object. According to the documentation, which you can review at this link, the promise returned by getBattery always resolves, which means that we only need to handle the resolve case. So battery promise.then and the function that tells our widget what to do next. The getBattery promise resolves with a battery manager object, which means that the callback will receive that object as an argument. So what are we going to do with that? Well, first here in the corner, I'm showing a log of what that battery manager looks like. And as you can see, it has a level float, which is from 0 for no battery to 1 for full battery. And it also has a charging boolean to represent whether your laptop is currently charging. So we're going to set the text in the charging box to yes if charging and no otherwise. We are also going to display the percentage, so battery level times 100%. And finally, to make it prettier, we're going to use a Font Awesome CSS class. We have 4 classes available from FA battery 0 to FA battery 4. So let's multiply the level by 4 and round it, and we will have our various battery levels. And that is a case where only resolve needs to be handled. As an extra note on coding style, there's no reason to create the battery promise local variable, and we can simply write navigator.getBattery.then, which is more readable. Now for an example of widget where we need to handle both resolve and reject, let's revisit the location widget. You may remember that when we ask the navigator to get the current location, the browser actually asks for permission to use your location. So clearly we could have a case where the user clicks block instead of allow, which means we need to handle a rejection. Let's open app.js, and what we're going to do is we will let Angular handle the display, but where we used an Angular deferred and promise object, we will now change to an ES6 promise. That will also show you how similar the two implementations are. Let's find the Angular service we had built called location service, and ES6 does not use deferred. Instead, we're going to return new promise function, and inside that function 2 callbacks, resolve and reject. We don't need to modify the call to get current location, except that resolve is a function by itself, where before it was on the deferred object. So simply resolve bracket geo. Now for the rejection, get current position actually takes 2 callbacks. We only provided the first one, which is called when the user agrees to provide their location. So let's add the second one, an anonymous function, and inside we will reject the promise by calling the reject function. For information, what we receive as argument in the callback is a position error. If you would like to log it into the console, you can see that object later. So just add console.debug arguments here. Scrolling up to the controller, because Angular promises and ES6 promises share a very similar API, the .then call here already works. The only thing is that we need to add a $scope.digest call after setting the variables on the scope. This is an Angular thing when using external functions. If you're familiar with it, great. Otherwise, just disregard it. Now to handle the reject case, we have 2 choices. The first is to add a second function in the .then method. So comma function And here, let's just set scope.coordinates to be an object with latitude not available and longitude also not available. You could decide to handle the error in many other ways, like an alert, for example. And here as well, we need to use the scope.digest for changes to take effect. Now, before I demo this, let me show you the second method to handle the reject, because in the end they have the same effect. The second way is to extract the callback we just created out of the .then, and instead to put it into another method of promise objects, the .catch method. So we close the bracket after the resolve callback and continue with .catch and then use that same function. Doing so tells the promise object this is what you need to do in case of reject. So which of the two is better? I think it's just a matter of taste, although there's a very slight difference between the two, but nothing noteworthy at this stage. So let's switch to the browser and have a look. Before every test, you will need to clear the permissions you had already given here in the top right corner. Then refresh the page and the browser prompts for permissions again. And if this time we click block, the promise gets rejected and the coordinates are now displayed as not available in the widget. Very quickly, for the case where only rejection matters, all you need to do is to use a .catch on the promise without a .then. I'm just going to create a quick fake example here with a promise that we simply reject and attach the .catch on it straight away with an alert. By the way, you can actually use .then and put null as the first argument to the same effect, but that's really quite ugly, so let me just revert to the .catch. And in the browser, you can see the expected result. If you are wondering what kind of application would need to handle only reject, here's a simple example. Think about a session heartbeat. When you ping a server via Ajax just to keep a session alive, if things go well, you don't want to do anything, but if they go wrong, you want to relog in the user. So that would be such an example. Now back to app.js. If we look at the handling of the promise outcome here with its .then and .catch, you can see that this flow behaves very much like a synchronous try-catch block. We try to get the geolocation, and if we catch an error, here's what we do. That is why people sometimes refer to promises as the asynchronous try-catch. Now, depending on which language your background is, you may be used to having a finally block, which happens no matter whether an error was caught or not. And you can see in our code that we really could use such a feature because both in the .then and in the .catch, we do a scope digest at the end. Now, ES6 promises decided not to implement that, whereas Angular does have it. So let's quickly revert to an Angular promise in the service here. Once again, you can see how similar the two versions are, the only difference being the use of a deferred object versus an executor. Now in the controller, let's remove the two scope.digest, and after the .catch call, add a .finally bracket and then a function. And we don't want to do a digest this time because we're already using Angular anyway. So instead, let's just alert a message that says location done. Note, by the way, that this callback does not receive any argument, so don't expect to receive the resolve value or the error message. If you need to access those, focus on the .then and .catch callbacks. Now in the browser, we can see that this alert pops up regardless of whether the user decides to allow or block the location. So it behaves as you would expect from a finally block in a try-catch. It executes regardless of success or failure. So in this video, we have reviewed the various ways of handling resolve and reject outcomes, whether it's only one of the two or both cases that matter for the application. In the next video, we will highlight how resolve and reject do not allow for second chances and how that can, in certain situations, be turned to our advantage. In the previous video, we reviewed the various ways the outcomes of a promise can be handled, depending on whether we care about resolution or rejection or both. In this video, we will discuss how resolution and rejection are a single chance occurrence, and how you can only pass a single value to the corresponding callback. As opposed to events, which allow the same trigger to happen several times and at unexpected times, promises allow for only one settlement. Whether it is reject or resolve does not matter. We will not be able to change that outcome, nor the value attached to it. To show the single chance and single value properties of promises, we are going to use very simple examples first. Later on, when showing how to use this property to our advantage, we will revert to widgets and create a geolocation type ahead. Let's code the examples in app.js. We're simply going to create three promises, A, B, and C. For A, we will resolve first and then reject. For B, we will reject first and then resolve. And for C, we are going to resolve twice, the second time using a different value. And in both cases, we are going to pass two arguments. On all three promise objects, we are setting a .then with two callbacks, which simply uses console.log for resolves and console.error for rejects. Now let's have a look at the result in the browser. And as you can guess from what I've explained earlier, promise A will only see the log that says I've been resolved, because once we have resolved it, it is too late to try and reject. There is no second chance. We will not see the I've changed my mind, I am now rejected console error. Similarly, for promise B, we will see an error, I've been rejected, because the reject comes first, but we will not see the second message because resolve after reject does not have any effect. Finally, for promise C, even though this time we are not trying to change the type of outcome, we will still only see 42 being logged. This shows two things about the resolution. One, that even the resolution value cannot be changed after the promise object has been settled. And two, that only one argument from resolve will reach the .then callbacks. The other arguments will be discarded. So this confirms what we have discussed, and that's a very important feature of promises. They are a one-time chance for the completion of the action, and a resolved promise cannot be made rejected, and vice versa. Let's see a use case for which we can turn this feature to our advantage. We're going to build a type ahead widget, which will search for city names using Google's geocoding API. If you have a look at the index.html file in the bundle for this video, you can see the markup for the new widget. There's an input on which we will listen for the key press button, and then two spans, one to display the city name that the API returned, and later the other to display the time it took to load. So let's move to app.js, and within a DOM content loaded event, let's add the event listener on key up. So var input equals document.getElementById city input, and then input.addEventListener, and we listened for key up, function. Now within that function, we are going to create a new promise, and in the executor, run an AJAX request. So var client equals new XML HTTP request. Now on this, we need to listen to the onload event of that request, pass the response, which will come as JSON, and resolve the promise with the first result. Let's open the client using a get method and point it to the Google Geocoding API with the current value we read from the input. And lastly, just send the request, so client.send. Now we need to handle the outcome of the promise with a .then, and what we receive in the callback is the result from the geocoding API. And so we're going to say if result, let's display the name of the city on the page. It's quite straightforward. So let's switch to the browser and let's start easy by typing, say, Paris. And yes, we get Paris, France as the result. But let's mess with it a little bit. I'm actually throttling my connection, so it pretends to be a 2G phone speed. And I'm going to type very quickly, let S, and then change my mind, delete, and just type S. Now, what is the result on screen? Well, it looks as if the search result for the letter S is a place called Let in France, which really can't be right. The reason for this can be found in the network inspector in the DevTools. As you can see here, this particular query, the one that was started when the text said let's, took a long time, whereas the one for the letter S took much less. And so even though I typed S later, Well, the API return that came last was from the let's call. And that is quite a common issue with typer heads, especially with slower APIs, because we do not know which call is going to come back first. So how do we use promises to solve that problem? Well, we're going to keep a reference to the reject function of the previous promise object outside of the keyUp event handler. So let's put var reject function, and at first we don't assign anything to it. Then in the handler, let's just check if reject function. Then we are going to reject that previous promise. We then create the new promise as before, and we keep a reference to the reject function by writing reject function equals reject. So by doing this, each time a new promise is created, we have a reference to its reject method outside. And since on keyUp we actually call that function, the previous promise will simply get rejected if it has not completed its API call yet. If it has completed, then the promise already resolved and calling reject will not do any harm. Now to prove that this works, let's add a simple console.debug inside the .then of the promise here. This should only be logged if we ever manage to complete the call to the Google API before a new promise is created, meaning before a new key is pressed. Let's get back to the browser with the developer's console open, and we can type anything in any order with backspace, etc. And it doesn't actually matter which API call completes first, because you can see here in the console that there is only one single instance for which we actually reach the console.debug, and that is for the last time we typed something into the input. It is actually interesting to note that for the other ones, where we use the reject function, there's a log and it says uncaught, meaning uncaught exception in promise. This confirms what we discussed in the previous video, that promises are the asynchronous version of try catch. If we added a .catch on the promise, those logs would go away. And so using the single chance property of promises, we have fixed an issue caused by the uncertainty of duration of asynchronous processes. One more thing about the promise resolution and rejection is related to the settlement value, which means the value that we pass to either the resolve or reject functions. It's important to remember that this is a value, singular. We cannot pass more than one argument. So for example, if we wanted to implement the timing of the search, as mentioned earlier, and display the amount of time it took, we would not be able to, let's say, call resolve and then brackets with the result, and then add another argument being the duration. I'm just going to put a fake one here. And let's change the .then signature to expect a result and a duration, which we will then log. Now if we have a look again in the browser, you can see that the logs only contain the result object, and that the argument we expected to be duration is actually undefined, instead of the 500 milliseconds that we used inside resolve. Again, this is not a limitation you need to worry about. This being JavaScript, you may be limited to one argument, but that argument can be anything you want. A string, an object, an array, even a function if you wanted. So to code the timing feature, we'll just use a start time when the new promise is created, and we will resolve with an array this time, containing the result object first and the duration next. Let's amend the .then function. It now receives an array. Let's call it data. And the first element of the array is result, while we use the second element for the timing. Back to the browser, you can see that the search is still successful and that we are now displaying the number of seconds that the search took. So in this video, we emphasized the unicity of the resolve or reject settlements, and we have shown how we can actually use that to our advantage in asynchronous flows. In the next video, we will focus on the callbacks that are attached to the promise via the .then and .catch, and how we can add multiple callbacks to a promise, as well as the timing at which they are called. In the previous video, we focused on the unicity of resolve and reject. Promises can only have one outcome, and even the outcome value is final once it has been set. In this video, we will discuss how the handlers of the outcome are exactly the opposite. You can add as many as you want from various parts of an application. We will confirm that callbacks set on the wrong path will never be called, and see that you can even add handlers after the promise has been fulfilled. And we will briefly compare this behavior with that of event-based processes. Let's start with very simple examples. We will reuse the A, B, and C promises before going into a more practical example using an enhanced geocoding widget. So we've set the promises A and B to resolve and reject respectively after a random amount of time, somewhere between 0 and 3 seconds. So let's add several callbacks on promise A, and then on promise B, and then a few more on promise A again. We're just logging some messages in the console, by the way. And now let's switch to the browser with the dev console open to see the result. You will see slightly different results if you refresh the page several times, because promises A and B are on a random timer, meaning we do not know which one will complete first. But in all cases, as you can see in the console, all the resolve callbacks on promise A are being executed, and all the reject callbacks on promise B are also being executed. The rejects on promise A are not being called, which confirms what we have seen before, that only callbacks that are on the correct path of the promise will be executed. One more thing that you notice is that the order of execution of the callbacks is not random for a single promise. Looking at promise A, for example, however many times you reload the page, the order will always be promise A was here too, and finally promise A is so busy. This is because internally, promises keep an array of callbacks that they need to execute, and each time we call .then, the callback gets pushed into the end of the array. So the execution order follows that array. First function in is the first function executed. But note, however, that there should not be any reason for you to have to rely on that knowledge. And if you are at some point faced with a case where you need to know which callback executes first, then you probably would need to look into combining promises instead, which is the topic of section 4 of this course. Here we simply added callback one after the other, so this might not seem very useful. So let's have a look at a practical example. We're going to create a new widget for geolocation, which will use the same promise as the existing widget. That new widget will actually get us the address of the current location using the Google Reverse Geolocation API. So opening app.js, you will see that we've created a global function which returns a promise if it already exists and creates it if it doesn't. That promise represents the process of getting the geolocation from the navigator. It is an ES6 promises, and we're going to use it both in the old geolocation widget and in the enhanced one we will create now. In order to keep the current widget working, we changed two things. First, the Angular service uses that new global function, and second, we added a digest in the .then method and in the .catch, while removing the .finally, which ES6 promises do not implement. That way, we have switched the widget back to using ES6 promises. We will check and confirm later that the original widget still works. For now, let's have a look at index.html, and we added a new box for the widget with a span with an ID of address, into which we will write the address once we have it from the Google API. So back to app.js, once again, things need to be wrapped into a DOM content loaded event, and in there we will call the getGeolocation global method, which will give us a promise object. And that is the same promise object that the other location widget receives, because we are only creating a single promise object. So let's grab our DOM element var address equals document.getElement by the address, and then we call the getGeolocation function, and on the promise that we receive we add two callbacks, one .then and one .catch. In the .then, meaning the resolve outcome, we expect to receive a geolocation object as argument, and what we'll do next here is actually calling another API to get the address. So we will create an AJAX client, set the URL to point to the Google Reverse Geocoding API, and we need to include the latitude and longitude in that URL, which thankfully are available in the geolocation object. The code for using the AJAX client is very similar to when we created the city name widget. We create the client, listen to the load event, and then send the request. The main difference being that when we are inside the load event, we're just going to use the response to output the address. So address.innerText equals, we pass the JSON response, grab the first result and use the formatted address, which is nice and readable. Of course, we should also handle the case where the user decided not to entrust us with their location, and for that we will follow something similar to the other location widget by setting the address to NA in the .catch callback. So here what we did is that we actually added two callbacks for one geolocation promise. One is added in this new widget, and of course one is added in the old widget. Alright, let's confirm that everything is going well on the browser. Once again, we want to clear the settings for location so we can test both successful and failure behaviors. We can allow for location, and you can see the coordinates appearing in the first widget, and a little bit later the address appears in the new widget, the delay being caused by the extra call to the Google API. Or we can disallow location, and both widgets will show NA immediately. Alright, so we have seen in a practical example that multiple callbacks can be added to a single promise, and all of them will be called. Note that we didn't bother with the order of the execution of the callbacks because, as mentioned before, we should not rely on that for our handling of flows. Now, before we finish this video, there is one important feature that we need to review. What happens when a callback is added after fulfillment of the promise? Well, one great thing about promises is that they represent a state in a flow, not so much an event that is triggered and then forgotten. So let's modify the cities widget a bit to be biased towards our location so that results are more relevant. So in app.js, let's locate our cities widget, and where we were making a call straight to the API, instead we are going to ask the browser for its location, so we can use the bounds parameter of the Google Geocoding API. We don't want to once again call the browser's getCurrentLocation. Instead, we're going to use the promise that is already being used by the two location widgets. So within the promise, we'll write getGeolocation.then and a callback. That callback receives a geolocation object, and we'll just move the AJAX call into that .then function. Now to use the bias, we'll add the bounds parameter to the URL, and the bounds parameter is made of 2 points that represent the zone we want to bias. So we'll just take our current latitude and longitude and minus 0.1 on each for the first point and add 0.1 on each for the second point. Now to show a bit more clearly what is happening, let's put some console logs in a few relevant places. First off, let's remove all the promise A, B, and C at the top because they just create noise now. And in the getGeolocation function, we will change the call to resolve into an anonymous function just so that we can add a console debug. So you will see that we do not get the location more than once. One more log goes into the address location widget so that later we can confirm that when we add the new .then callback, the promise has actually already long been resolved. So what are we expecting? We should see the getGeolocationReceived message first, and it should only be there once. And then the getGeolocation promise will be resolved, which means we will have the using geolocation promise in location widget message. The next callback that gets added to that promise will be set later only, when we start typing into the cities widget. So you can see in the browser with dev console open that this is indeed the correct outcome. And that confirms that the promise returned by getGeolocation has already been resolved. And yet, even though the promise has already been resolved, when we add another callback, when we type into the cities input, the new callback simply gets executed immediately. And that is fantastic about promises, because it allows you to use them to represent a state. And there is no such issue as missing the moment where the promise resolves. So that is quite different from events where if you've missed an event, then tough luck, you can't go back and add callbacks and hope that they will be triggered. So in this video, we emphasized on the handlers for promise outcomes, which have the exact opposite features compared to resolve and reject. Any number of handlers can be added. Having no handlers at all works as well, by the way. They can be added from anywhere in the application, and they can even be added after the promise has been fulfilled. This makes promises a great tool for asynchronous state and thus flow controls. Now, Angular version 2 is one of the very hot topics on the web, with lots of breaking changes to be expected, some features disappearing and new ones being added. So in the next video, we will discuss where promises stand in this major overhaul. As you know, Angular v2 is coming, and it brings along a large number of breaking changes and totally different concepts. So where do promises stand in that overhaul? In this video, we will first briefly discuss the implementation that is proposed for Angular v2 promises. We will then get hands-on and create a very simple Angular 2 app coded in TypeScript. We will see how to use fetch to grab data from an API and the JSON method to pass the data and display it on screen. The proposed promise implementation for Angular 2 is found at this link. One nice thing about Angular is that it does not attempt to reinvent what browsers do well, only to improve on it. And so you will find that Angular 2 promises will be simply using the native ES6 promises, which is great news because it means that everything we are learning in this course will apply to Angular version 2. The only added features will be the ability to use a deferred object as an alternative to the executor, as well as a mock promise service for testability. So let's see how we can build a very simple Angular 2 app with promises. But before we can start, let's make sure that you have all the tools needed. You will need to install Gulp globally. And next, within a terminal, go to the code bundle folder and cd into the ng2play folder. From there, run npm I to install the node dependencies locally. And finally, run gulp play. This will compile the TypeScript into JavaScript and launch a HTTP server on port 9000. So this is what you should see now in your browser. Let's now open hello.ts in that same ng2play folder. By the way, don't worry if you are not familiar with Angular 2 yet, this example will be extremely simple. Also, if you are unable to complete this short video because of dependencies problems or similar, please know that we will revert to more familiar things from the next video onwards. So here you can see that we have an hello app component, and it is created via this class, which has a constructor. Currently, the value of the name is world, but we will load a name from an API. So within the constructor, let's use the modern replacement for AJAX calls, the method called fetch. It takes a URL, so let's use a mock data API, and fetch actually returns a promise. So we will type .then and the callback, which receives a response. The response itself has a .json method, which returns a new promise. So .then again, and this time we get the object from the API in the callback. We need to set the name onto the component itself. So outside of the fetch, let's write var self equals this. And now in the callback, we can write self.name equals object.name. Let's open the browser, and you can see the name changing to the value we received from the API. So really, this is great news because everything we are learning in this course is relevant to Angular 1, ES6, as well as Angular 2. In this section, we learn how to create and use ES6 promises and how to resolve or reject them. We've learned about the unique fulfillment and unique resolution values. We also learned about multiple callbacks that can be added on a promise even after it is settled. Finally, we had a glance at Angular v2 promises, and we can now safely continue learning more features of Angular 1 promises, knowing that everything we learn will also be relevant to Angular 2 and plain ES6. Talking about more features to learn, in the next section we will cover 4 awesome ways that promises can help us handle asynchronous flows. Welcome to the third section of the course entitled One Man's Garbage is Another Man's Gold. As we will see, the outcome of a promise can be considered success by one action, but failure by another, and vice versa. So we'll see how to deal with that. There are several difficulties in handling asynchronous flows, and in this section we will go through 4 of the features that promises implement and that can help handle such flows. So we'll start with, first of all, executing several asynchronous actions in series, which we call chaining promises. Next, we will learn to transform data or promise resolution value to make it more usable for the next process. Then we will look into 2 features that are similar, where we will turn a promise that was resolved into a rejected one, and in reverse, we will also make a reject into a resolve. But let's start off by building a flow of asynchronous processes. When using a series flow, we call that chaining promises. So in this video, we are going to start by showing that every one of the handler setters, which are .then, .catch, and .finally if you're using Angular, well, all of them return a new promise object. And we will use that to chain the setting of handlers. But more importantly, we will see how we can keep the flow going by returning a promise in each step. To illustrate those concepts, we will create a weather forecast widget for your current location, which consists of 4 processes in series, each one needing the outcome of the previous in order to proceed. So to get started, we're going to open the developer console, which is convenient when you want to test simple things out. We're going to create a first promise. Let's call it promise 1. And here's a useful trick to create a promise that simply resolves. You can type promise1 equals promise.resolve and pass any resolution value. So if you have a look at what promise1 is now, you'll see that it is a promise object, which by the way is in the state resolved, with value 42. But we're not really interested in that at this stage. What is more interesting to us here is that we're going to use .then to add a callback to this promise. And what the .then call will return is actually a new promise. Let's do this. Promise2 is equal to promise1.then, and let's add an empty callback for resolution. And you can see that indeed, promise2 is also a promise object, and it is quite clear that it is a different one because its state is different. It is pending. You could also check promise2 triple equal promise1, and you will get false, which confirms that promise2 is a brand new promise. Let's do this one more time with a .catch this time. Promise3 equals promise2.catch, and again, any callback will do for now. And we get a new promise again, which is confirmed when typing promise3 triple equal promise1. And that shows false. So every time you add a new handler on a promise, you get a new promise object. Let's see how those 2 promises relate and how we can use this to our advantage. Alright, let's set up our new widget, a weather forecast for your location. Open index.html, and we have added a new div element as for all the other widgets. Now, because we intend to display data along the way, let's use Angular. Although we will not use anything that is incompatible with ES6 promises. So let's set a controller for that div element called weather forecast controller. And in order to see the process unfolding one step at a time, we will have a first paragraph in which we will display the geolocation as latitude and longitude. Next will be the actual address, or rather the city and the country. And finally the forecast and a temperature display. Now, I've mentioned before that it is a good thing when working with more complex flows to actually write down what are the various steps involved. Let's do this here. The flow will be as follows. First, we will get the geolocation from the navigator. We've seen how to do that. Then we will call the Google Reverse Geocoding API to get our current address, from which we will extract the city and the country. Next, we will call the AccuWeather Search API to transform that city and country into an ID, which is internal to AccuWeather. And finally, we will ask AccuWeather for the forecast using that ID. Of course, each one of those processes is asynchronous, and the process in its entirety is basically one big asynchronous process made of several building blocks, and it has 2 outcomes. Either we display the forecast or we alert an error message if something went wrong anywhere along the way. So here we will start to really grasp how much promises can be helpful. Okay, let's move to app.js to prepare the code. So we'll create the weather forecast controller, and let's request all the services we need. $scope to display things, $HTTP for the API calls, and the location service we built earlier, which wraps the navigator's getCurrentPosition into a promise. The first action is to get geolocation using that location service, and that gives us a promise, so we can write .then and a callback, which receives a geolocation object. Let's call it geo. For a bit of visual, we'll write the locations on the scope. So $scope.latitude longitude equals the latitude coordinate plus the longitude coordinate separated by a comma. Now within the callback, meaning once we have got the coordinates, we need to call the Google API. Let's do this with a $HTTP call, which uses the latitude and longitude in the URL. Again, this is a promise, so we'll type $HTTP.get, the URL, and follow up with a .then. The callback receives a full response object in which the data is contained inside response.data. It has an array of results. Let's use the first one. And that result itself has an address components array. Here we'll briefly work on extracting the data, basically iterate through the components, and only grab locality and country. After this process, a query should be an array of 2 strings, one for city and one for country, which is what the following API from IQWeather needs. Let's display what we have on the scope, so $scope.city equals query.join, comma. Again, from within the callback, meaning once we have the city, we're going to call the search API point of AccuWeather. You can refer to the AccuWeather API documentation for more information, but basically we are calling a point using $HTTP.get, the URL, and we need to pass the city and country as a Q parameter in the URL. Once more, this will give us a promise, and so we continue with .then and a callback which receives a HTTP response. And we read the data from the first result again. We're almost there. Now that the result of the AccuWeather search provided us with an ID, we just need to make one last call to another AccuWeather API point. This one's slightly different because we point to the id.json, and we use $HTTP.get with the URL. And once again, that gives us a promise. So we attach a .then, which receives a HTTP response. That response has a result, which we can finally use to display the current weather and temperature onto our browser. Great, let's have a look at the result here. Here the location appears first, followed by the city name, and after a little while, the actual weather shows up. Now this is already pretty nice. Nothing was too troublesome along the way. But let's look back at the code, and there are 2 obvious issues here. First, each block is completely not reusable outside of this very specific flow. Also, you can see that our code is just moving towards the right a fair bit instead of really moving forward as the flow actually does. Now here comes the great thing about promises.then. Not only does it return a new promise, but if the callback itself returns a promise, the outside promise, the new one, will actually resolve and reject in the same way than the inside promise does. Don't worry, it will all be clear in a second. So what does this mean in our example? Well, instead of using a $HTTP.get to the Google API, and once again attaching a .then callback on that one, we can actually simply return the $HTTP.get promise. The then callback, which we had on $HTTP.get, moves one level up in the callback stack and one level left in the indentation. And that next function still receives the same response object that the $HTTP.get provides. So even though the next .then is not directly on the $HTTP.get call, as you can see here, it is on the same level as the original getGeolocation.then, but because we returned a promise inside the first callback, we will now receive the result of that promise in the next .then call. Now, besides looking nicer in terms of indentation, what's really great is that this really closes the getGeolocation part of the flow. It is complete and we are not within its callback anymore. The next process, which is to grab the address from a latitude and longitude, is completely encapsulated. of course, we can apply the same concept to all the next $HTTP calls, meaning we don't put any .then on those calls anymore. Instead, we return the $HTTP calls, and the .then move back up in the indentation chain. The synchronous part, which is about finding the city from the list of address components, doesn't change, but once we have the city, we just return the new $HTTP.get call. And once we do that for every step in the process, you can clearly see the code moving forward, and you can actually relate each of these clearly standalone .then calls to each of the boxes in the flow we drew earlier. This also means that we can abstract each and every one of these processes into services for better reusability. So this is what we call chaining promises, because as long as your .then callback returns a promise object, the promise will be executed in series, with the outcome of the previous promise becoming what the next .then has access to. And that simplifies asynchronous flows tremendously, almost making them look like synchronous if-else statements, or rather try-catch statements. So in this video, we have learned how to chain promises, which allows us to handle a series of asynchronous events in a very clean manner. As you could see though, in $HTTP.get calls, we are receiving entire response objects. If we created a proper service to abstract the loading of some data, we would want the controller to receive data only, not a full HTTP response. So in the next video, we will learn how to modify the resolution value of a promise, and thus how to make API data user-ready. Welcome to this next video, where we will learn how to modify and prepare data to transform it from a raw API response into displayable content. In the previous video, we learned how to create a flow of asynchronous processes and how to keep that flow going by returning new promises at each step. However, in our example, you may have noticed that each action was very dependent on the outcome of the previous one. Not so much whether it was resolved or rejected, but rather that one step needed to be aware of the format of the previous outcome. For example, here we needed to pass a JSON response and extract an ID out of it, whereas what is desirable is that all we get is the ID, not the entire HTTP response. In this video, we will take the resolve value much more into consideration and prepare data to be in an already relevant form before being passed along to the next process. This will also make the abstraction of each of our asynchronous building blocks much stronger. We will actually construct the logic service in such a way that it contains two layers of abstraction. As a practical application of this, we will build a widget which loads the list of repositories from a GitHub username. Let's open the index.html file and see that we have prepared the markup for the widget. It consists of an input to key in the username we wish to look for, and a list which gets repeated over the repositories. And you can see from the ngBind that we are going to expect only the names of the repos in the list. So repositories here will need to be an array of strings. There's also a Go button on which the user will click to trigger the search, so it has ngClick equals get user repos, which we will need to code. Moving to app.js, let's first create the controller for the widget. As per the markup, that's .controller, repositories controller, and a function, and that function takes the dependency injection items. We will need $scope, and we will also add a service which we will create shortly. Let's call it GitHub service. For the controller, we only need to code the getUserRepos function, so scope.getUserRepos equals to a function. And we will call a method on the GitHub service, let's call it getRepoNames, which will take a parameter scope.username. Now we will make sure that the getRepoNames function returns a promise, which resolves with an array of the repository's names. So we can continue with a .then and a callback with parameter repoNames. Since we get names directly, all we need here is to set $scope.repositories equals to repoNames, and they will be displayed. So that's all for the controller. Moving on to the service, we are going to use a factory, so .factory, to create the service called GitHub service, and then the constructor function with the dependencies. In our case, we just need to make AJAX calls at this stage, so $HTTP is the only service we require. In a factory, the service is the object that you return, so let's write var service, which is an object, with a method called getRepoNames. That method takes a parameter, namely the username, and we're going to return that service object. So to get the list of repositories for username, we're going to make an AJAX call to the GitHub API, $HTTP.get, and then the URL, which is the GitHub API plus username, and then /repos. Now that $HTTP.get call gives us a promise, so we can return that. But if we return this promise directly, the resolution value is going to be an HTTP response object, which contains headers information, HTTP status, and of course the data. But we do not want the controller to have to be aware of the business logic, and indeed we coded the controller in a way that it expects an array of strings, certainly not a full HTTP response. This leads us to the next great feature of promises. If we create a new promise by adding a .then here on the $HTTP call, whatever value we return inside the callback will become the resolution value of the new promise, the outside promise, if you will. In our case, the .then callback of course still receives the HTTP response as argument, so function response. Now we can already extract the data, var data equals response.data, and then let's iterate over the items in the array to extract the names. And finally, let's return the array of names. And now what happens in the getRepoNames function is that we are returning the new promise, the one created by the .then callback. And because within that callback we are returning an array of repo names, that array will be the resolution value of the outside promise, which we can then use directly in the controller. Let's have a look at the result in the browser. Let's type a git username in the box and click go, and you can see the list of repositories being populated. Returning now to app.js, in the service we have therefore seen how we can modify the resolution value of a promise simply by returning the new value from within the .then callback. The exception to this would be if we return a new promise, of course, because that would allow the asynchronous flow to go on, as we have seen in the previous video. Let's think about reusability of the current code though. Granted, we only wanted the names of the repo in this here widget, but there could be another widget that needs the entire repo objects, or maybe only the IDs. And so it would be great to have an extra layer of abstraction, a method whose job is only to load the data via AJAX, and we can build other functionalities on top of that function. So in the service, let's create such a function. Let's type getRepos as a new property of the service equals to a function. Now this will need to take a username parameter. And then the function will return $HTTP.get brackets and then the URL, which we can cut and paste from the other function. And once again, we only want the data to come out of this, not the full HTTP response. So we will continue with a .then function bracket response, and we'll change the resolution value by returning response.data. So now we have a function available whose job is only to grab a list of repositories for the given username. It does abstract the API call though by resolving with the data only and not the full HTTP response. What does this mean for the other function, getRepoNames? Well, we're not going to redo the HTTP.get call here, otherwise getRepos is kind of useless. So instead, we will return service.getRepos with the same username and continue that with a .then function brackets data this time. Remember, we are getting data only from getRepos. And that's a list of repository objects. So to make that new promise resolve with strings only, we just extract the names and return the array. You can check the result in the browser. It will be the same as previous. But what really matters here is how we manage to create reusable building blocks by using the feature of promises that allows us to change the resolution value along each step. GetRepos abstracts the API call by returning a promise, which resolves with an array of repository objects, and GetRepoNames makes use of that promise and abstracts the extraction of names. Note that all those building blocks, all those methods, return promise objects, which makes it easy and predictable to work with each of them. You can easily imagine creating more methods on the service that would make use of the getRepos function, maybe one that gets only private repos, or one that simplifies the repo objects. So in this video, we learned how we can modify the value that gets passed from one promise to the next, and how we can use that to create well-abstracted, reusable service blocks. But there are cases where we need to do more than just modify the value. We actually need to modify the direction that the promise takes, switch between resolve and reject. Let's see how to change a success into a failure and why that can be useful in the next video. Welcome to this next video, changing successes into failure. Both this video and the next will be about changing the direction of an asynchronous flow. So far we have seen how we can keep an asynchronous flow going by returning a promise within a .then callback, and how we can modify resolution values by passing them along into the next block in the flow. But there are times where it is not enough to just change the value, we need to change the actual path that the promise is taking. As you know, there are only two possible outcomes for promises, reject or resolve. So we will see how we can make a resolve into a reject. As it might not be obvious at first, we will give a few examples of use cases for this feature. This will lead us to introduce $q.reject for Angular and the equivalent promise.reject in ES6. We will then apply this to the existing weather forecast widget to handle the case where the Google reverse geolocation does not yield any result. So as mentioned, there will be cases where you want or need to transform a success into a failure. Of course, each promise can only have one of two outcomes, and that can't be changed. We have seen that in section 2. But we also know that .then returns a new promise, and so it is that new promise that will allow us to change a success into a failure. Now, why would we ever want to do that? Well, you have to think of the asynchronous flow you are working with as one big promise with only two possible outcomes. And as an example, let's look at the weather forecast widget. We actually drew up the flow for that quite clearly, and you can see that there are some red arrows from each building block, though we kind of ignored them as we implemented the widget. But more than this, let's take the second part of the process into focus, the Google reverse geocoding. It's an API call, so you could get some 404 or 500, and that would be an obvious error. It would follow the red arrow. But what if we gave crazy latitude and longitude values to that API call? Well, here's the outcome of the geocode API with latitude and longitude in the middle of the ocean. Empty results and a status 0 results. Now, http.get is not going to fail. It is a success in the sense that $http.get call will get a status 200 for the response, which means success. But to the bigger picture, to our actual flow of getting the weather for our current location, this is clearly a failure. So that gives you a first clear use case of when we will need to transform a seemingly successful promise, here the $http.get is a success, into a failure, the fact that there are actually no cities at that location. Other use cases include login. Very often, when login fails, APIs still return a 200 but have an internal error status or a message to say credentials were invalid. So $http.get takes that as a success, but for the login process, that's actually a failure. Mismatched data is another use case. Maybe the $http.get call is successful, the login itself even is successful, but you could be working on a process that requires the user to belong to a certain user group. For example, administrators of a forum. So even though the API call is successful and the login is also successful, but to your process, the user that was authenticated could represent a failure. Actually, pushing it further, this idea can be applied to absolutely anything depending on your requirements. Maybe you are able to obtain the battery level of a device, which is a success, but for your specific process, a level of less than 20% should be considered a failure. Think, for example, about downloading a new version of iOS onto your phone. You'll need plenty of battery for that. Maybe you are able to get a user location, once again a success, but to you, location outside of a certain country are a no-go, so that's a potential failure. Or even some stranger cases. So this highlights to you that success and failure really are relative to what you are trying to achieve. But enough talking about it, let's apply this concept to the weather forecast flow. What if the Google reverse geocoding API succeeds, since the AJAX call is okay, but we have a 0 result status? So the first thing I'll do here is purposely fake our location to be in the middle of the sea. Coordinates 0, 0 will do nicely. To achieve that, let's use what we learned in video 3.2. Let's modify the resolution value by using a .then callback. So I'll insert a .then onto the geolocation, and instead of letting the real geolocation object go through, I'll create a fake object that sort of matches the original but with coordinates 0, 0. And if you look in the browser, you'll immediately see that we run into trouble because we assume that the API was giving us an array of results. Now, this is not a failure of the AJAX call. If you switch to the network tab in the dev console, you can see that the call with latitude longitude 00 is successful. It has a status of 200. However, that call's success can potentially be a failure for the entire process. So how can we tell the bigger flow that a status of 0 results actually means a failure? Well, instead of returning a certain value or a pending promise, we are going to return a rejected promise. So inside an if statement, if response.data.status equals to 0 results, let's return, and the easiest way to get a rejected promise in Angular is to use $q.reject, brackets, and as a parameter we can pass the reason for rejection. $q.reject, or the ES6 equivalent, promise.reject, are functions that simply return a rejected promise. We have seen in video 3.1 that when a promise is returned from within a .then callback, then the next .then receives its resolution value. It's called chaining promises, and it is what we're actually using here in this widget with each .then call. Well, actually the next .then does more than just receive the inner promise's value. It actually follows the behavior of that inner promise. And since we are returning a promise that we know is rejected, the path is now changed to a rejection instead of a resolution. Of course, it means that we need to handle that rejection, so let's add a .catch at the end of the flow here, and a function which will receive the reason for rejection as parameter, let's say message, and let's simply alert that. And now in the browser, you will see an alert pop up with the message we set as the rejection reason. And that is caused by our decision to transform the seemingly successful API call into a reject if no results are found. So we have achieved our goal of turning a success into a failure, but before we complete this video, let me highlight a small particularity of rejection. Going back to app.js, where we return a rejected promise, you remember how I've mentioned that promises are like an asynchronous try-catch? Well, how do you trigger a catch in a try-catch block? By throwing an exception. Well, you can actually replace the $q_reject with a throw. Let's say throw the string error no good. And the promise will consider that as a rejection, with the string here being the rejection reason. And the flow will go into the .catch handler. By the way, you can throw anything in JavaScript. It does not have to be an error object. And once again, looking at the browser, we see the alert popping up. So the effect is the same because promises are like an asynchronous try-catch. Personally, I prefer focusing on promises, so I'd rather use $q.reject or promise.reject, but the choice is yours if you feel that throwing an exception is clearer. So in this video, we learn how to change the direction of a flow from success to rejection and discuss some use cases where this pattern can be useful. As your application's flows grow in complexity, you will find that this feature is actually used very frequently. As a side note, we also correlated rejection with throwing exceptions. So here we have made a resolve into reject, and in the next video, we will make failures into successes. Welcome to this video, turning failure into success. As in a previous video, this will be about changing the direction of an asynchronous flow, but from failure to success this time. So we're going to look at how to proceed in order to turn a failure into a success. Because it might really not be obvious why we would do that, we will provide a few use cases. The practical application we will use here will be a widget to check whether a given repository name is available for a certain GitHub user. Finally, we'll summarize all the features related to process flow using promises that we have learned about in this section. So how do we turn failure into a success? Well, that's pretty straightforward. All we need to do is to return anything that is not a rejected promise. Whether we return a new promise, which as you know means we are continuing the asynchronous flow, or any other type of value, which, as we have seen in video 2, changes the resolution value in the next promise. Anything works so long as it is not a rejected promise. So let's do a real quick example in the developer console. Let's create a rejected promise. We have seen before that it can easily be done by calling promise.reject. So rejected equals promise.reject, and there you see the output. We have a rejected promise. Let's create a new promise by using a .catch on the initial promise. Promise2 equals reject.catch function, and in the callback, let's simply return a value, let's say 42. And now type promise2 to see that this is another promise with a resolved status. So we've transformed a rejected promise into a resolved one. Now, this is a feature for which you might be wondering, why would I ever want to do this? So let's talk about a few use cases for it. What we will use for our actual widget is an example of desired opposite outcome. That means that you are in a process where what usually is considered bad or failure is exactly what you wish for. In a widget, a 404 status, which HTTP regards as a failure, is exactly what we are hoping for in the global process, since it proves that a given repo does not exist. So if you're checking for the absence of something, maybe a flag or a domain, this will be such a use case. Another type of application is recovery or setting default. For example, in a forum, a user could have a profile picture, but it has gone missing. So in this case, when you attempt to load the image, you get a 404 error. Unlike the previous use case, we're not happy with that, but we still want the display of the profile image to be successful. So we can make the 404 rejection into a resolve, maybe with a default image. Finally, a good use case for this is to handle non-critical failures. Consider a heartbeat used to keep a session alive. If you receive a 403 error not authorized, that's critical for the session. It means it has expired and we need to somehow inform the user or prompt them to log in again. But what if you receive a 404 or something that signals that the user is maybe out of internet connection, maybe temporarily? We do not want at this stage to consider this a failure until we can have a real check with the server. So there are several types of use cases for this. And of course, as you create your own services, you will consider success and failure differently for different applications. So let's get into a practical application, the widget to check repository availability. If you open index.html, you will see that we have set up a div with an ng controller equals to GitHub repo availability controller, as well as two inputs, one representing username and one representing repository. Finally, a button with ng-click, check repo availability, allows the user to trigger the check. Let's get to coding the corresponding logic. So in app.js, we'll add the controller called GitHub repo availability controller, and then we need to inject the $scope, and we're going to make use of the GitHub service that we created earlier. Note that we could do the $HTTP calls straight in here, but having the good habit of abstracting logic into services is an important part of building flows. The one function we need to code is $scope.checkRepoAvailability, that's a function. And within, we are going to call the GitHub service checkRepoAvailability method with scope.username and scope.repository as parameters. And that will give us a promise. So we continue with a .then, and we will code the checkRepoAvailability method in a way that it straight away resolves with the availability status. And we will use that status on the scope. Now, since it's always a good thing to prepare for errors, let's add a rejection handler for which we display that scope.status equals an error has occurred and add the reason for the rejection. Let's scroll down to find the GitHub service, and we need to code the checkRepoAvailability method, which, according to what we wrote in the controller, should take a username and a repo name, which we will use to create the URL. So let's return $http.get, and the URL is built using the username and repo name. Of course, if we just return this way, we are returning a promise, which is a good start. But if this promise is rejected because of a 404 error, we actually want the method to return a resolved promise, a success. Since we need to handle a rejection, this time we will continue with the process with a .catch, and the .catch will receive the HTTP response as a parameter. Now we'll check for the status, whether it is 404, in which case we will simply return the string available. So simply by returning anything, as long as it's not a rejected promise, we transform this rejection into a successful promise. One more touch, in the controller we are expecting the status to be just a string, and right now if the repo is not available, we're not doing anything, which means that the promise will resolve with a full response object. So as we did in video 3.2, we are going to transform that resolution value by squeezing in a .then function, which receives response as argument. And since it's a success, we don't really care what's in the response, we just return the string not available. Alright, let's have a look at the result in the browser. I'll type my own username and a random name for the repo, click go, and there you have it, it's available. Whereas if I type an existing repo, it will say not available. Now let's summarize what we have seen in this entire section about what happens depending on the return values of .then or .catch handlers. As you can see in this table, the same actually happens whether we are within a .then or a .catch callback. So what really matters isn't so much the previous promise, it is more what we return in the callback. So if we return a promise within the handler and that promise is resolved, then the outer promise will also be resolved with the resolution value of the inner promise. If we return any value, the next promise will also be resolved with the value we just passed. And in the case where we return a rejected promise, the next promise will be rejected as well with the same reason. It is the same effect if we throw an exception. So in this section we have covered all the possible directions and value changing that promises offer in an asynchronous flow. So far it's only been actions in series, one after the other. That already takes care of a fair amount of asynchronous applications. However, promises are even more powerful than that because they can be combined with each other. And that's what we will talk about in the next section. Welcome to the section about combining promises, which will show another great feature of promises related to process flows. In section 3, we have made good progress on asynchronous flows. We know how to redirect a flow, prepare values before passing them on, etc. In this section, we will talk further about how promises can help us easily handle asynchronous flows. We are going to start with a case where we have several asynchronous actions running in parallel. This will be pretty straightforward. In the next video, we will see a really great tool which allows us to run processes in parallel, but wait for all of them to be complete before moving forward. Finally, we will look at a series flow, but with a twist this time, since we will, on the fly, define how many asynchronous processes we will run in series. Let's start with parallel and independent tasks. This case will be very straightforward. We will create several promises to each represent an asynchronous task, and we will let them run. For each of the promises, separately, we will handle the result using a .then. Within the code, we will add logs so we can see the order of the processes. As an example, we will build a widget that displays the current number of people in space, as well as the current location of the International Space Station. Let's open index.html and have a look at the markup created for the widget. Once again, we have a controller which we will code, and within the panel body there are two columns, one to display the list of people in space using the ng-repeat here, and we can see that we're expecting iss.people to be an array since we used the length attribute to display the number of people. And in the second column, we'll be displaying the current latitude and longitude of the International Space Station. Let's get started on the controller. We will need $HTTP since the information we need can be obtained from the OpenNotify API. So let's dependency inject $HTTP. We create the $scope.iss empty object. We will add its properties as we receive the position and list of people. The information comes from two different API points though, so let's create var peoplePromise equals $http.jsonp and then the URL to get the astros. We have to use JSONP because CORS is not implemented on that API. And then create position promise equals $HTTP.jsonp and the URL that provides the current position information. Let's handle the results of the two promises, starting with peoplePromise.then and a function, and we will receive a HTTP response. We want to grab the data, and on the data we'll find an array called people, which is exactly what we need. Let's add a console log here so we will see later when this task completes. Moving on to the position promise, we are more or less doing the same, but this time it's data.issPosition, which we assign to $scope.iss.longitude to match the index.html markup. Add a console log within the .then callback, and let's also add one more console.debug outside of those promises. Now this part is synchronous, so it will always complete first. We're ready to switch to the browser with the dev console open. You can see that the data is loaded independently for the position and the people. As expected, the synchronous part is always going to be first, but if we reload the page several times, you can see that the position call sometimes completes first, sometimes after the people API. This is something we always have to keep in mind when working with asynchronous flows. There is no way of knowing which process will complete first. So in this video, we saw a simple example of two promises that run concurrently and independently. We also pointed that in an asynchronous flow, we can never assume to know the order in which tasks complete. This can sometimes lead to race conditions if the tasks are interdependent. In the next video, we will see how promises help us deal with that problem. Welcome to the next combination of promises, interdependent tasks. In a previous video, we confirmed that we can easily run processes in parallel using promises and handle their outcome completely separately. What if, however, two processes can be run in parallel, but in order to continue with your flow, you need to be sure that both have completed? We will see how we can handle that extremely easily using queue.all, which returns a new promise. We will discuss how we receive an array of results and how the items are ordered within. And we'll discuss what would happen if any one item fails, meaning one of the promises is rejected. As an example, we will use a common problem that often leads to race conditions, loading a video ID to be played from Twitch TV and at the same time loading the player itself. The player is loaded asynchronously, and of course, so is the call to the API. Let's dive straight into the code, looking first at the template we have put in place in index.html. We have the widget in a full-width div element handled by a controller called Video Player Controller. The div with ID Twitch embed player will be used to hold the player itself. We just added an ID for convenience. Below the player, we have a list which simply displays the values found in a status array. And what we will do is push the current status into that array as we go along so we can follow the progress. And note as well that at the top, we have included a library called SWF object, which will allow us to load the player. Let's get to coding the corresponding controller code, starting with defining the controller, .controller brackets video player controller, comma function, and here come the dependencies. We need $scope to display status on the screen, and we will also need $q to handle the player events and to combine the promises. And finally, $HTTP to call the API and ask for a movie ID. Let's initialize things next. To handle the player, first we will create a deferred object, var player loading equals q.defer, and the corresponding promise, var player ready equals player loading.promise. Also, to keep track of the progress along the way, $scope.status equals to an empty array. To create the player, here's the snippet we use with the library SWF object mentioned earlier. We point to the Twitch player SWF object, and the second parameter is the ID of the div into which the player should go, and then some options. An important option here is the events callback, which is the name of a function that the player will use whenever it wants to trigger events. So we need to code that. Window.onPlayerEvent equals, it's going to be a function which receives an array of events each time, and we'll check whether the first event is player init, which is the initialization event. When that happens, we are going to resolve our deferred object, playerLoading.resolve, and since we are going to need the player element within our .then handlers, let's resolve using that div element. So document.getElementById, Twitch embed player. So now the player ready promise will be resolved. Let's add a .then handler on it, player ready.then function, and it receives the player as a parameter, although we will not use it at this stage. The moment the player is ready, let's add a message to the array of status so that it gets displayed below the player. So $scope.status.push, just a simple message, player is ready. Now to get the ID of the video we wish to play, we're going to make a call to the Twitch API, var video ID equals, and since the API doesn't support CORS, we will use $http.jsonp, and here's the URL which searches for top videos in the gaming shows. Add the .then handler, this will receive a full HTTP response object, and what we'll do is first add a message to the status, video details loaded, and we will return response.data.videos and pick the first video object. As you know, returning a value here means that video ID is now a promise, which resolves with that specific value, in our case, a video object. So we are all set now with both our processes, and they are running in parallel. We don't wait for one before starting the other. However, when the player loads, we can't give it the ID unless we already have it from the API. And when we get the ID from the API, we can't pass it to the player unless that player is ready. So for us to now load the video onto the player, we need to wait for both processes to complete. So the two tasks are interdependent. Enter q.all, which helps us handle such a case. q.all takes an array of promises, here the player ready promise and the video ID promise, and q.all gives us a new promise, which will only resolve when all the promises in the array have resolved. Since q.all returns a new promise, we can continue with a .then function, and that new promise resolves with an array. Let's call it results. To show that both the player has loaded and the video ID is available, let's push a message into $scope.status, say loading video onto player. This message will definitely come in last. How about the array of results then? Well, that array will contain the resolution value of each of the promises passed to q.all in the same order as those promises. So that means that var player will be equal to results 0 and var video equals results 1. Watch out, this is not the order in which the tasks complete. It is the same order as the $q.all array here. Player first and video second. You can refer to the code above to see what the resolution values are. A video object from video ID and the player div element from the player ready. And so all we need to do now is player.loadVideo and video._ID. And now we guarantee that there will be no race condition. Both video and player will be there before we attempt to play. Let's check the result in the browser, and you can see here the status being populated. The video details are loaded, then the player, and finally we load the video onto the player and it starts playing. Of course, depending on the quality of the connection to the Twitch API, the player could be loaded first. But you can be certain that loading video onto player will only happen after the previous two. Before closing up on q.all, let's consider what will happen if any one of the promises fail. Let's simply reject the player promise, player loading.reject no player, and add a rejection handler on the $q.all promise, so comma function, and it receives the error message. Let's simply alert that. Looking at the result in the browser, well, as you would expect from the name, q.all requires all promises, and so as soon as a single one rejects, the q.all promise rejects as well, and the alert is triggered. Note, by the way, that the original promises are not stopped or cancelled, they still proceed, but the new promise that q.all gave is rejected. In this video, we learn how to build a promise out of several promises with the guarantee that both will complete before the next task is allowed to continue. In section 3, we have already spoken at length about series flow, how we can redirect or change the value, and you should be quite comfortable with series flows at this stage. So in the next video, we will add a twist to the handling of processes in series by considering a case where the number of tasks actually varies. Welcome to the third video of the section. In section 3, you have used a fair amount of series flow and should be quite comfortable with that right now. So instead of talking about a normal series flow, we will add a twist to it. The twist will be that we will run a number of API calls which isn't defined from the start and that the user can change. In a synchronous environment, we would use a simple for each statement, but we will demonstrate why this would not fit our requirements here. We will then create a chain of n promises and handle the result of the last call. The example we will use for this is an API response time, where the user will provide an API and the number of times they want to ping that API, displaying a total and average duration for the calls. Let's have a look at the index.html where we have put the widget in place. We have a controller for the widget called loadTimeController, two inputs, one for the URL we want to call and one for the number of times we wish to hit it. Here's a go button which will call a check function to start the process. For display, we will use the scope variables duration and average, which are bound to the two spans here. Moving to app.js, let's create the controller and inject the services we need, $scope and $HTTP. Let's define some default values for the URL and set times to 10. And when the user clicks, it will call $scope.check, which is equal to a function. So in this function, we're going to first keep the start time, so var start equals to a new date, and we'll also define a promise for the whole flow, which for now is undefined. Now we're going to iterate over the number of times selected by the user, which we find on scope. As mentioned, let's start with a normal for statement and call $http.get scope.url those n times. Well, even before trying to go and see what happens when we do this, we know we have a problem, because on which of these promises should we add the .then to measure the time? Let's consider our options. We can add the .then on the last value of I. So if I is less than scope.times minus 1, we just call the API, and else we call the API and we add the .then handler in which we calculate the duration and the average. Let's see the result in the browser with DevTools open. You can see that the calls are not made in series, they are all starting at the same time. And as we get only the last duration, which is likely to be the longest, we are crowding the API. And of course, we wrongly divide by the number of calls to get an average, when we actually only measure the one call. So this is not the right way to go. Let's head back to app.js and consider a second option, something that we have actually just learned, namely using queue.all. That will actually not fix the issue as per requirements, since the calls will still be in parallel. This will give us the slowest case, guaranteed. And I think this is a very interesting example of use of queue.all with a varying number of items. So let's go through it. Outside the for loop, let's create an empty array var promises equals to an array. And we don't need that if statement right here anymore. Now let's cut the then handler and keep it for later. We're going to push a new promise into the promises array each time. So promises.push, $http.get, scope.url, and add a .then to allow us to modify the return value. Let's return the duration of the current call, which is obtained with new date minus start. Outside the for statement, we'll just add a queue.all and the array promises, meaning wait until every call is done. Paste back the .then method, and what this promise receives is an array of the durations of each API call in order. Note that we need to dependency inject $q in the controller, by the way. We can keep the $scope stuff here for show, although they are still not correct and based on the slowest result anyway. So let's have a look at the result in the browser. I'm going to purposely pick a low number of API calls, let's say 3, so you can see very clearly what happens. You can see the 3 calls made and each of their duration in the Dev Console Network tab. And compare that with the resolution values seen in the console. They're a good match with an extra few millisecond cost for creating the date objects probably. And of course, the slowest result is the one that will appear on the scope since it waits for all the calls. As mentioned, an interesting use of queue.all and one that hints at the actual correct version because it shows that even though the iteration is synchronous using a normal for statement, the execution is asynchronous. So how are we actually going to do things in series? Well, remember that as long as you return a promise within the .then callback, you keep the flow going in series. So how can we do that each time? Well, simply by keeping the promise variable equal to a new promise each time. On the first iteration, promise will be undefined, so we need to check that if not promise, and in that case, we'll set promise to be equal to $http.get and the URL which comes from the scope. After that, when promise is already defined, we'll say promise equals promise.then, and in the callback, we will simply return $http.get with the URL again. So here at this stage, the promise variable is a promise object because every .then call returns a new promise. And because in each .then callback we also return a promise, namely http.get, we are actually chaining promises. All that is left is to handle the last promise after we created the flow of n times calling the API. And we'll do a usual promise.then, and within the callback, let's get the duration equals to new date minus start. We set that value to scope.duration for display, and then average will be duration over scope.times. This looks great. If you look at this code at a glance, you could barely guess that this is a flow of asynchronous processes. Let's move over to the browser once more and make sure to have the developer console open with the network tab filtered by XHR. Now click on Go, and you can see each API call being made one after the other. And at the end, the result is displayed in our widget. So in this video, we have seen one more example of using flows in series, this time with a varying number of tasks being executed one after the other. You now have all the tools you need to handle any form of asynchronous processes, however complex, and the knowledge to make such a process easy and clear to handle thanks to promises. In the next section, we will see a few extra topics about promises, such as faking asynchronous processes when you are in a synchronous process, and why we would do that. And we will compare promises with events, because both have their place in the new JavaScript ecosystem. Welcome to the last section of the course. At this stage, you are already armed with all the tools needed to handle asynchronous flows, however complex. This section will cover quite various things. We will start with a video on making synchronous processes appear asynchronous and why we would do that. We will look back at one of the widgets and spot a pitfall which occurs when not returning any value within a flow. We will also have a comparison of promises versus events, since both are ways of coding in asynchronous environments. And we will complete this section with an ES6 specific feature, the promise.race method. Let's start by looking into the concept of making synchronous tasks appear asynchronous and why. In this video, we will talk about two reasons to make more things asynchronous. The first one is when a value is of unknown type, more specifically, if we are unsure whether or not it is a promise. As an example, we will create a search in the iTunes movie library with a very simple caching mechanism. The second reason is actually to purposely make a synchronous call appear asynchronous, and to illustrate why, we will future-proof a to-do list widget. For this video, we have already built two fully functional widgets, which we will enhance. The first one is an iTunes search widget. We simply type a term in the input, click Go, and it fetches matching movies from the iTunes API. The template for the widget is really straightforward, so let's directly look at the app.js file and find a controller called iTunes controller. Everything is already coded to work fine. As you can see, it does not call the API itself, but rather uses the iTunes service to perform the search. So it calls iTunes service.search using the search term and returns a promise, as is recognizable by the .then handler. It then slices results and puts them on the scope. The idea here is for us to implement caching within the service without having to modify the controller. So let's scroll down and look at the service iTunes service. It contains a search function which, as expected, returns a promise. So everything is working. But let's say we wanted to add a very simple caching mechanism. Let's have an object defined outside of the service, var cached results equals to an empty object. And every time we complete the search and we have the response, we will save those results using the search term as the key. Then, every time we call search, we will first check whether search term is already cached. So if search term in cached results, then we want to return the results straight away. So return cached results search term. So a nice and simple catch, but one with an obvious problem. The controller actually calls .then on the return value of the search method. So when our service returns an array of results instead of a promise, this will break. In comes $q.when, whose job is to wrap any value into a promise. So instead of returning cached results search term, we will return $q.when brackets cached results search term. And now we know that we are returning a promise object. Actually, this is slightly less than what $q.when is intended to do, because we knew that the array is just a value and not a promise. Q.when can actually also be used on a promise object, in which case it will leave it alone. So a nice way to write the search method would be, without the if statement, return Q.when brackets cached results search term, or, if unavailable, $htp.jsonp, etc. So the Q.when is wrapping both the array of cached results and the $htp call, which is a promise. Regardless which it is, $q.when ensures that we receive a promise object as a return value. I invite you to have a look at the result in the browser and to search several times for the same keyword, without reloading the page of course, and to see the AJAX calls being made only one time for each keyword. So now we know about the first reason to use $q.when, which wraps a value for which we are unsure whether it's a promise or not, and guarantees we get a promise. Let's consider another important reason. The second widget we will use here is a to-do list. Once again, it is fully coded and fully working if you'd like to try it out at this stage. Now let's look at the controller. As you can see, we abstracted the logic into a service called to-do service. That service implements a load, add, and clear methods. You can also see quite clearly that all those methods are synchronous. Scope.todos is set to the return value of load, and there's no sign of .then handlers. Let's scroll down to the corresponding service, and indeed, you can see that it implements load, add, and clear using local storage. All these methods are synchronous, since local storage is synchronous. Now imagine that for any reason, a decision is made to change the storage, and to use something more modern, like IndexedDB for example. Well, that's an asynchronous storage, which means that as we implement it, we are going to have to change to asynchronous, and thus change the API of this service. And that in turn would mean changing the controller code. Now, one of the rules of using services is that they should abstract logic so that it becomes transparent for controllers. So it would be much better if, from the start, the service was considered async, so that regardless what storage is used, the controllers using that service do not need to be changed. One could argue that if we plan async, what if we move to synchronous later? Well, there's a simple reason for picking asynchronous. Making something synchronous look or appear asynchronous is actually easy, but making something asynchronous appear synchronous is hard and error-prone. So given the choice, always go asynchronous for processes that might at any time be changed from async to sync, or vice versa, especially since now you are really skilled with asynchronous flows using promises. So how do we modify the code to use local storage but be asynchronous? By the way, I'm reverting the service code to the local storage, but I'm leaving the controller to expect asynchronous behavior. So let's focus on load first. All we need is to load the data from local storage as previously. var data equals local storage.getItem todos, and wrap the JSON parsed value inside a $q.when call. You can write this without using a local variable in a one-liner, but that's a bit less readable. And that takes care of the load function. Now add will return service.load.then function, and the parameter will be the old data. Inside the .then, push the new item to the old data and save it again. There's no need to make that specific part asynchronous, we only care that the public interface of the service is async. And why not return to do so that the controller knows this is the value we just added. So add now returns a promise which will resolve with a value equal to the new task that was added. The clear function is very simple, just return $q.when, brackets, and the remove item call. We could actually call remove item and then return q.when with any parameter, since the resolution value isn't used anyway. And that's it. With these few changes, we have now future-proofed the to-do list service so that its interface is asynchronous and thus ready to use things such as IndexedDB. So in this video, we saw two examples of using $q.when, one to wrap a value into a promise in case we are unsure whether it's already a promise, and one case to make asynchronous processes appear synchronous, because that is better future-proofing than trying to do the other way around. As a note, the ES6 equivalent of $q.when is promise.resolve. Now in the next video, we will look back at one of the widgets we created earlier and see how there's a missing part in the code, which leads to a pitfall. And of course, we'll discuss how to fix that problem. Welcome to the pitfall of no return. To quickly explain the problem we're going to talk about, we will go back to the widget for GitHub repo availability, which was created in the Turning Failure into Success video in section 3. As we will see, we need to consider what happens when the process takes a path where there is no return statement, and why there should be something to watch out for. And of course, finally, we will make sure to handle the cases correctly. So let's look back at the widget we created in that video, the GitHub repository checker, looking at it from the browser perspective. In the first input, we type a username, and in the second input, a repository name. Then press the Go button, and it will tell us whether that repo is available for that specific user. Looking at the code now, in app.js, scroll down to find GitHub Availability Controller as well as the GitHub service. And you might recall that we called the checkRepoAvailability method with the username and repo name. And in the service, that method basically did a get call to the repo URL, and if it received a response to 100, it would return not available. But if it got an error 404, not found, we made that into a resolution by returning the string available. This was the example that introduced how to change a failure, 404, into a success. There is, however, one case we didn't handle properly, which I will demonstrate now. Let's start by opening Chrome and the DevTools. Open the Network tab, and in the throttling option, set to offline. This is an awesome tool, by the way, to check how a page behaves with slow or no internet. And to really be able to follow the flow, I'm going to add breakpoints on app.js inside the .then and the .catch of the $http.get call, as well as on the two handlers in the controller. Of course, what we would expect is that the HTTP call will be rejected, and that the whole process will be rejected as well, because the error will not be a 404. Let's click the Go button on the widget and see. Well, $http.get is indeed rejected. The execution stops here. We can mouse over response to see that it has a status 0, meaning it will not go into the 404 case here. But when we continue the execution, surprise, it goes into the resolve handler, not the reject, even though we did not enter the return available part of the code. And the status here is undefined. Well, to remind you, as we have highlighted in section 3, in a promise flow within a .then or a .catch handler, if you return anything that is not a rejected promise, the surrounding promise will be a resolved one. Now, in JavaScript, if you do not provide a return statement, it basically is the same as returning undefined. And since undefined is not a rejected promise, our rejection has become a resolution with undefined as resolution value. So that is clearly a pitfall we need to watch out for, though it's quite easy to fix. Let's move back to app.js, and in the service method, let's make sure that for all cases that are not 404 status, we return a rejected promise. We can simply add return $q.reject brackets and maybe the response's status. Watch out that we have not used $q in this service yet, so we need to dependency inject it into the parameters here. And let's verify in the browser that this time we correctly display an error has occurred and the status, which for no internet has the value 0. So in this video, we learned about the pitfall of failing to have a return statement within a certain path in a .catch handler, namely that the surrounding promise will be considered resolved unless we specifically return a rejected promise using $q.reject or promise.reject in ES6. In the next video, we are going to compare promises and events and see how to decide which to use in various scenarios. Welcome to this next video where we will compare promises with events. Promises and events are two different ways of handling asynchronous processes. Events have been the only way to go for a few years, and we will first go through some of their characteristics. We will then review the corresponding features of promises and compare how they differ from events. Lastly, we will look into a perfect example where both those great tools have their place. But before that, we will go through a checklist that makes it easy to decide whether to use promises, events, or a combination of the two. We've been talking at length about promises, so let's instead start by looking into events. Probably the main feature of events, and what makes them still useful today, is that events can be triggered at unknown or unexpected times. In the case of promises, we don't know how long a process will take, but we know it's going to complete. We are expecting completion. Events, on the other hand, can be triggered at totally random times, and they can be triggered multiple times. Let's quickly see an example of those features simply by adding an event listener on key up on the city input of world cities. Input equals document.getElementById by ID city input, and let's add an event listener with the name of the event we're listening to and the callback to execute as we type. You can see that the process is not starting and ending, it's continuously there, as opposed to what we aim for in a case of promises. And the number of times it gets triggered is incremented each time as well. Now, because they are not starting and finishing, events can only take a single pass. If you wish to inform of a failure versus a success, you'll have to trigger a different event. They can, however, take many values. This is because there is no plan to combine events, so the API on them can vary from one implementation to another. Of course, we can add many handlers for a single event. And something that's quite important is that the handlers are added on the object that's sending the events, which means that you rely on that object implementing the event behavior. Finally, one of the sometimes restricting properties of events is that when you miss an event, say you add a handler after the event has been triggered, it's too late. You'll never see the event triggered. Now, how about promises? Well, we spoke at length about all those things, so I'll go quite fast here. First, promises are great to represent a flow which we expect to start and then complete. It might be after an unknown duration, since it is asynchronous, but we are expecting completion. A promise can only either resolve or reject, and that will only happen once. There is no way to re-trigger a promise. Promises only allow for a single value for resolution or rejection. This makes them great to combine with other promises, because we know exactly what to expect. As is the case for events, many handlers can be added, but unlike events, the handlers are added on the promise object itself, not the object that triggers completion. And last but not least, handlers can be added after resolution or rejection, making promises great for knowing the state of a process. Promises do not in any way attempt to replace events. They only attempt to provide a new, more tailored tool for developers when handling closed processes. So in a minute, we are going to look into a case where both events and promises can be used in conjunction with each other, each doing the part of the job it is most suitable for. For this, we will look at a YouTube video player. And for that widget, we are going to simply display statuses depending on what is happening with the player. The four things we will consider are the YouTube API being ready, the player itself being ready, a video being started and completed, and the player being paused and started at random times. So how do we determine for these actions which should use a promise and which is better off with events? Well, here's a quick checklist that should serve you quite well in your decisions for projects to come. First, ask yourself, is the action happening as part of a flow or unexpectedly? Asynchronous does not mean unexpected. You can have a process that takes a long time, but you know it is going to complete. Also, does the event occur more than once? Clicks, typing, etc. usually can be expected to happen several times, so events would be needed. But the DOM being ready happens only once, so that would work very well with promises. What happens if we miss a notification? If the completion is something we really can't miss, meaning that the state is really what matters, then promises will be great. Do I plan to combine this with other actions? Events are rather tough to combine, promises are not. And finally, can I consider the process I'm looking at as a self-enclosed, complete flow? If yes, promises are the way to go. So in app.js, we've cleared the video controller code for the Twitch TV widget and instead inserted the code to load a YouTube player. It's pretty clear from the checklist we just mentioned which process will be best served by promises and which will benefit from the properties of events. API ready and player ready are definitely single-time triggers, and missing those events should not stop us from proceeding. It's all about the state with those. So this has promise written all over it. Playing and pausing a video, however, is clearly totally unexpected and can be done multiple times, even for a single video. So that will use events. An interesting case will be that of a complete video being played. As mentioned previously, promises are great when handling a process that starts and expects to finish at some point in the future. So even though one could argue that playing a video happens several times, playing a video from start to end is a full enclosed process and will work well with promises. Let's start by coding the API ready. When the tag that contains the YouTube API is ready, it will call a function on window called onYouTubeIframeAPI_ready. We'll make that into a promise base by creating a deferred object and keeping the corresponding promise in a variable. And we'll just say that onYouTubeIframeAPI_ready is API loading.resolve, meaning when the iframe is ready, resolve the promise. Next, since API ready is a promise, we'll add a .then handler, and once again we will use a promise to validate the readiness of the player. On that promise, we will add another .then handler, which will just change the status to say the player is ready. And now let's create the player itself using the div ID as first parameter and an object with options including the size and the video ID. The events property of the player is itself an object with keys representing the event and the corresponding function to call when those events are triggered. On ready, we will have a callback where we resolve the player ready promise. And finally, when the state changes, we will call a onPlayerStateChange callback, which we will code in a minute. As you can see, the player ready was actually event-based because events were, until ES6, the only way to go for libraries. But we made it promise-based, which I think is more suitable. The final part is the onPlayerStateChange function, which receives an event as argument. And as mentioned previously, the process of playing a video from start to end will be considered as an enclosed action, so we will have a video player promise, which we will keep throughout events, until we get an unstarted state, at which point we initialize that process by creating a new promise. Or when we have a ended state, at which case we resolve that promise. On the promise itself, we add a .then handler again, just changing the status here. But of course the idea would be to do more out of this, maybe serving an ad or offering related videos. Playing and paused are two more states we need to handle, but those are not going to be promise-based, as they can change unexpectedly and several times even per video process. We just added a $scope.digest to ensure that the status is updated on screen. And so now in the browser you will see the status change as the API becomes ready, then the player, and as we play and pause several times, we trigger the events. And lastly, if we reach the end of the video, the promise is resolved and we get the other status message. So in this video we discussed events as opposed to promises, and we saw that both have their place in asynchronous environments, depending on what your needs are. We also created an example that actually uses a combination of both those tools. In the next and final video, we are going to talk about one more feature of ES6 promises called promise.race. Welcome to the last video of the course, Race to the Finish Line. In this video, we will look into a new feature of ES6 promises called promise.race. Promise.race is similar to promise.all, which we talked about as $q.all in the combining promises section. It takes an array of promises and returns a new promise, and that promise will resolve or reject as soon as any one of the original tasks resolves or rejects. As it completes, that outer promise has the same resolution value or rejection reason as the fastest promise. So unlike promise.all, we don't have the information of all the original promises, only from the first one to complete. There's no better way to illustrate promise.race than building a little race widget, so that's what we'll do next. Let's dive straight into the code, open index.html, and let's review the markup. We're still going to use Angular for convenience reasons, to wait for DOM ready and for the click handling, but we will actually code in vanilla ES6 JavaScript for the logic itself. So here we have our controller, race controller, and a button to trigger the start of a race. We then have set up a racetrack and 3 divs, one for each car. There's also a result box, which will display an image of the winning car. The racetrack, 3 cars, result box, and winning car image all have IDs on them for both styling and later coding convenience. Talking about styling, if you open app.css, you can see the corresponding CSS applied to the elements we just mentioned. Basically, the cars are positioned absolute within the racetrack, and each car receives a different Y position and a background image. What we'll do is use translate 3D to move the cars to the right towards the finish line. The result box has some visual styling, and at the start it is hidden using the display none here. And here's what the widget looks like in the browser with the styling. Now let's get to the actual logic code. Open app.js, and we've already declared the controller and the selectors for the important elements car 1, 2, and 3, result, and the result car image. We've also got the distance that needs to be covered, which is calculated from the width of the racetrack minus the width of the car and minus the width of the checkered finish line. So the moment the position of a car exceeds that distance, they will have completed their race. So what we will do is, at intervals of 10 milliseconds, we will move the 3 cars to the right by a slightly random number of pixels. And we will consider each car's race from start to finish as an asynchronous process. It starts when we click start and ends after an unknown duration, so it is perfect to be represented as a promise. Let's code the race promise for car 1, and then we'll see how to make that reusable for all cars. So var car1 race equals new promise, and you remember in ES6 the promise takes an executor function, which itself receives 2 callbacks, resolve and reject. We're going to start the movement method using setInterval function, and we want that triggered every 10 milliseconds. Now within that function, let me just paste the code for moving the car. It basically creates a random number of pixels, passes the current position of the car using the translate 3D style, adds the move by value to that current position, and sets the new position on the element. And then we will now check the new position, whether it is higher than the distance to cover, and if it is, we will resolve that car's race promise and pass the car object itself as resolution value. Now, because once the car finishes, we want to stop the others, we're going to need to keep the reject method as well as the interval, so let's set them on the car1 object. car1.reject equals reject, and car1.interval equals to the set interval. We would of course need to do the same for each car, so let's extract that executor method, function race, and instead of car1 as the car object, we will make sure that the this object within the function call is each of the cars. So var car equals this, and then replace car1 everywhere with just car. Next, let's focus on the scope.start function. Since we'll do things for each car, let's have an array var cars equals car1, car2, and car3, and scope.start equals to a function. As mentioned previously, promise.race takes an array of promises, meaning that we want to have an array with a promise corresponding to each car. The array.map function is perfect for that. So var races equals cars.map function, and in the map callback we receive each car object. Let's create a new promise, var car race equals new promise, and the executor is called race. We coded it just now. But in that race function, we mentioned that we need this object to be the car, so we will add .bind car, so that in the race function, this refers to the car. What do we do with that promise? Well, let's simply add console logs so we can see things unfold later. Finally, we need to return the promise, so it goes into the races array. So now we have an array of 3 promises, each of them representing the race of a single car. But we want to trigger the result as soon as any one of the cars finished. So let's use promise.race. Promise.race bracket races, which is the array of promises. And since this gives us a new promise, we continue with a .then function, and the resolution value will be that of the fastest promise, which, if you refer to the race function above, the promise resolves with the car object. So we'll call it winning car here. When the race is over, we'll do a few things. First, we will stop all cars. So cars.forEach function, car, and we have kept a reference to the reject function and to the interval as well. So car.reject will complete the car's race, and clear interval car.interval to stop the movement. Because the winning car's race is already resolved, reject will have no effect on that one, by the way. And the next thing we do is display the result and set the result car image attribute to that of the winning car using its ID. The last missing piece is a reset method that puts things back into place and which we will call each time we restart the race. And we are all set to check what happens in the browser. With the dev console open, click Start to get the race going and see the logs. First, one promise resolves, and then immediately the promise.race promise also resolves, and we have race is over. Within the promise.race callback, we reject the remaining promises, so we see car1 lost and car2 lost. So it works great. And this brings us to the end of the course on learning JavaScript promises. We've been introduced to promises in both Angular and ES6 and learn how to resolve and reject those promises with corresponding resolution value or rejection reason. We reviewed ways of building an asynchronous flow and of changing its direction or preparing values before passing them on in the flow. We also used various combinations of promises in parallel, in series, interdependent promises, and just now as a race between several processes. Finally, we reviewed some extra features of promises, as well as compared them with the other commonly used asynchronous helpers, namely events. I hope you've enjoyed learning about promises, and I'm confident that you will make good use of this knowledge as more and more libraries and APIs rely on them for asynchronous processing. All source codes for the many widgets can be found on the Git repository of this course, and feel free to create issues on that repo if you have any questions related to promises or the course. Thank you, and see you again soon in the next course.